the very important concept related to polymers is its classification, which is done on the basis of several criteria, out of which 5 very important criteria are listed here. We are going to learn the classification one by one on the basis of different criteria. The first criteria is classification based on the source, from which source the polymer has been derived. On this criteria, the polymers are classified into 3 main types: natural polymers, semi-synthetic polymers and synthetic polymers. Natural polymers are those which are completely derived from the natural resources. Examples are proteins, cellulose and all the biomolecules which are related to the human or animal as well as plant body. Semi-synthetic polymers are those which are prepared in the laboratory, but the starting materials used for the synthesis reaction are derived naturally. Examples are rayon, cellulose nitrate, etc. The last type in this category is the synthetic polymers, which are completely man-made or artificial, synthesized in the laboratory. Examples are polythene, nylon, 6,6, buna S, melamine, etc. So many examples are there in this criteria, which we are going to learn in so much detail next. This is the definition for the natural polymers. Some examples for the natural polymers and the monomers present in them: carbohydrates, which are made up of the monomeric units called as monosaccharides, that is sugars. Examples are glucose, fructose are the monomeric units present in the polymers like sucrose, starch, cellulose, etc. Another example is of proteins, for which the monomers are amino acids. Next one is the nucleic acid, which is the genetic material present in the human as well as animals and plant bodies, that is DNA and RNA, for which the monomeric unit is nucleotide, hence they are called as polynucleotide. Next one is the natural rubber, which is made up of the monomeric unit called as isoprene, and the last example is wool, for which the monomeric unit is amino acid. This is the definition for the semi-synthetic polymers, for which natural resources are used as the substrate, starting materials. Some examples: synthetic polymers, completely man-made by using chemicals. Examples are polythene, PVC, melamine, etc. We are going to learn these examples in detail later. Let us have one question based on this classification. First criteria, based on the source. The question is, synthetic fibers are prepared from. So, synthetic fibers are nothing but the polymers. So, these synthetic fibers are prepared from, as they are synthetic, obviously they will be prepared from the chemical compounds and not from the other options cellulose, starch and polymers, because they are natural resources. Chemical compounds is completely artificial. So, option C is the answer for this question. Second criteria for the classification of polymers is on the basis of the structure of the polymer. On the basis of this criteria, the 3 classes are linear polymers, branched chain polymers and cross-link or network polymers. Linear polymers are those in which the polymeric or monomeric chains or monomeric units are linked to each other, forming a long or elongated chain. There is no branching in them. In branch chain polymers, the linear chains are connected to each other by the branches. In the cross-linked or network polymers, so many branches are connected to each other, forming a network polymer. Examples of linear polymers are polythene, polyvinyl chloride, etc. Branch chain polymers examples are low density polythene, LDP, and polypropylene. Cross-linked or network polymers examples are bakelite and melamine. The third criteria for the classification is based on the mode of polymerization. Polymerization reaction can be chemically an addition reaction or it can be a condensation reaction. In case of addition polymers, there are again 2 types of the polymers, that is homopolymers and copolymers, on the basis of which kind of monomeric units are involved in the reaction. We are going to learn this in detail again. Addition polymers. So, these are the polymers in which the polymerism or polymerization reaction is nothing but the addition. Obviously, as the reaction is addition reaction, the starting material or substrate or monomer should be any compound which is unsaturated compound. That is, it can be alkene, it can be alkyne, it can be diene, etc. The examples of the polymers which are made up of the addition polymerization, but by using two different monomeric units which are called as copolymers, the examples are buna S and buna N. Second criteria is condensation polymerization. On the basis of that, polymers are classified as condensation polymers. In this case, the monomeric units, or you can say two or more than two small monomeric units, are condensed with each other, leaving behind a small molecule or one or two small molecules, getting a polymer. So, in this case, the total weight of the polymer is less than the total weight of monomer, because the small units, or you can say small molecules like water, alcohol, are left behind from this reaction as a side product. In this case, the small molecules can be water, alcohol, HCl, ammonia, etc. On the basis of that, there will be the loss of weight in the polymer than the units of the monomeric units. Examples are terylene, which is also called as Dacron, nylon 6,6 and nylon 6. So many other examples are also there. Let us learn them in detail. In this case, the nylon 6,6 is made up of the condensation reaction in between hexamethylene diamine and adipic acid. The fourth criteria for the classification is on the basis of the molecular forces in between the molecules, in between the monomeric units obviously. On the basis of this criteria, they are classified into elastomers, fibers, thermoplastic and thermosetting polymers. In this case, these polymers are utilized in so many processes or so many fields due to their mechanical strength, or their strength which is totally different than the addition polymer due to the condensation reaction, and the other properties like tensile strength, elasticity and toughness, that is hardness. Obviously, these properties are due to the intermolecular forces in between the molecules, and on the basis of what kind of forces are in between the molecules, like van der Waals forces or hydrogen bonding or other dipole-dipole interaction, etc., the polymer will be accordingly strong or weak, tough or hard, like that. In this case, greater the length of polymeric chain, stronger the intermolecular forces in between the particles or molecules.